So we're going to do today's video, which is on rational equations. So let's go ahead and get started on the do now. So what is the least common multiple of 2 and 5? And the easiest way to do that is to list what the multiples are. So multiples of 2, 2 times 1 is 2, 2 times 2 is 4, 6, 8, 10, 12, and we can keep going. Multiples of 5 are 5, 10. As soon as we see that the multiples are the same, sure, as soon as we see that the multiples are the same, we can stop. So the least common multiple between 2 and 5 is going to be 10. So 10 is our least common multiple, okay? What is the least common multiple of x and x plus 1? So there are no common factors between x and x plus 1. So the least common multiple is going to be x parentheses x plus 1. There's your least common multiple, okay? For this one right here, we're going to factor. So what is common in both? X squared means that we have two x's minus 3 times x. So what is the same? We can see that there's an x and an x that are the same. So we're going to take that x, we're going to factor it out, and we're going to write down what's left, right? So if we take this x out, we have one x left. And we can verify that because x times x is x squared. And then if we took out this x right here, there's a minus 3 that's left. And again, we can verify that by x times negative 3 is negative 3x. Okay, so this is factored as much as possible. Done. All right, so for this one right here, we have to get the denominators to be the same. So just like we did in the do now, the least common multiple between 5 and 2 is going to be 10. So to get this, let me go ahead and change this color. Let's do this. Sure. To get this 5 to be a 10, we multiply the bottom by 2. Whatever you do to the bottom, you do to the top. And we do the same thing over here to get this 2 to be a 10. You multiply this 2 by 5. Whatever you do to the bottom, you do to the top. Multiply this by 5. As soon as we see that our denominators are the same here, see how the denominators are the same? So 5 times 2 is 10, 2 times 5 is 10, and then 10 is right there. And we also have an equal sign between this, right? See this equal sign? So as soon as we have that, we can cross out the denominators, right? And then we have a simple equation. 2 times 4x is going to give us 8x, plus 3 times 5 is going to give us 15, is equal to x plus 1. And this is something that we know how to solve, so we have to get the x's by itself. So let's go ahead and move this x over here. So 8x minus 1x is 7x. This cancels out. We bring down the 15 here is equal to 1. Let's do minus 15 minus 15. So we get 7x is equal to negative 14. Divide both sides by 7. And we get x is equal to negative 2. Okay. The next thing that we have to do is plug, it says step 4 is plug in the solutions into the original to see that it works. Okay. The reason why we're doing that is to make sure that we don't have any zeros or undefined on the bottom. Today's Delta Math was about seeing if something is undefined or not. I just want to show you another way to check it. So we do have x is equal to negative 2. So here's another way to check it, okay? So if this was a multiple choice question, you could do this straight on the multiple choice, but let me just show you. Let me go ahead and erase all of this right here. So we're going to go back to what the original problem was, and we're going to plug it into the calculator, okay? So whatever's on the left side of the equal sign, we're going to plug it under y1, and whatever's on the right side, we're going to plug it under y2. So how do we do that, right? Alpha y equals gets us the fraction, so we do 4x over 5 plus 3 over 2. Exactly what's here, we plugged into the calculator under y1, and then for y2, we plugged in whatever's on the right side, which is x plus 1 over 10, and then we hit graph, and we can see that we have two lines, and they cross somewhere around here. So if we go hit second trace, option number 5 is intersection. We're going to move our cursor or our mouse, move it till it gets to where they intersect about, hit enter, 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 and it gives us x equals negative 2. So x equals negative 2 actually winds up working. So there's our answer. Okay. This question for model problem 2 says to do this algebraically. So you can't just plug it into the calculator. If you do plug it into the calculator and you get x equals whatever, that would give you 1 point, which again, 1 point's better than no points, okay? All right, so for this one right here, we're going to start out very similar. Let's do purple. All right, so we have x minus 1 and x, and then over here we have x squared minus x. So the first thing we want to do is go ahead and factor out the denominator right here, which is going to be x parentheses x minus 1, and again we can check it by x times x gives us x squared, x times 1 gives us x, and there's a minus sign between it. So this one has a 1 on the top. Okay, over here I'm just going to rewrite this, x minus 1 minus 2 over x. Okay, so what we need to do next is we need to figure out, let's go orange, we need to figure out what do we need to multiply by x minus 1. So over here we have the x minus 1, but what's missing is our x, right? Our x is missing over here. So we're going to multiply the bottom by x, and we're going to multiply the top by x. Okay, so let's do that. So we're going to multiply this by x and this by x. Okay, so now our denominator looks like this one. Okay, so here we have x, and what's missing is the x minus 1. So we're going to multiply this by whatever is missing. Multiply this by x minus 1 as well. And now our denominators are the same, so we can cross them out. Beautiful. And then we can use this to simplify, right? X times x gives us x squared minus 2 parentheses x minus 1 is equal to 1. And this becomes something that we could have done in algebra 1. So let's go ahead and solve this baby. So we can do distributive property here. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. And we bring down that x squared, and we bring down the 1. Okay. So now we need to move everything to one side. So minus 1 minus 1. So this cancels out. And we're left with x squared minus 2x plus 1 is equal to 0. Beautiful. Now we can double bubble this. Let's see if we can figure this out. So two numbers that, remember the little x that we were making before? So the b term goes on the bottom. So we're looking for two numbers that add to give us negative 2, and also that multiply to give us positive 1. So 1 times 1 is 1, and 1 plus 1 is 2. However, this is negative 2. So let's put a negative and a negative here. So let's check that. Negative 1 times negative 1 is positive 1. Check. And negative 1 plus negative 1 is negative 2. So we have x minus 1, x minus 1 here. And the next thing we're going to do is we're going to set this, both of these right here, we're going to set it equal to 0. So x minus 1 equals 0 and x minus 1 equals 0. Common sense might say, hey, that's the same thing. So we'll add 1 here, add 1. So we get x is equal to 1, which means we're going to get x equals 1 here, right? 1 minus 1 is 0. So x equals 1. So this is what we think our answer is. Now we have to plug it back in. But there's something that happens here, right? Let's talk about this real quick. Let's go back to the original. So we have x equals 1. Problem is, if we put a 1 here, 1 minus 1, we get a 0, right? So isn't that undefined? Yes, it is. So that means that x equals 1 is not a solution. So there is no solution for this question, which is the little brackets, which with the little O in the middle with a line through it, or you could just put open brackets, or you can write no solution. Okay, so there's no solution for this problem. All right, and again, if you were to take this, plug it into the calculator. Let me pause and do that. All right, so now that we're back, I went ahead and plugged in whatever was on the left side of the equal sign, which is this right here. I plugged it under y1, and whatever is on the right side, I plugged it under y2. And then if I hit graph, you're going to be able to see. So the blue line is the first curve, which is the first part of the, right, y equals y1. And this part, the red line, is y2. And we can see that they never actually meet. You could go to the table and confirm that all of these above are errors. Right, so if you go over here, this one right here, the 0 and the 1 is error, but if I look over here for the y, I'm looking for where these two are the same, and there's not going to be any part that they're the same. If we look across from 1, which is what we got algebraically, across from 1 they both say error. Okay, so we can also prove it that way, that it does not work. All right, good. We're in a good spot to go ahead and stop. If you want to learn model problem number 3, we do this the same way. Factor this, so we get an x and an x. Two numbers that add to give us -4 and multiply to give us 3 are 3 and 1, negative and negative. So on the top we have a 2 is equal to, and over here we have 2x over x minus 1 plus 1 over x minus 3. So we start out the same way, look to see whatever is missing. So the x minus 1 is there, but the x minus 3 is missing, so I multiply the bottom and the top by x minus 3, and I do the same thing over here. Multiply this by x minus 1, which is whatever is missing, x minus 1 over here. Now that the denominators are the same, they cancel out, and I'm left with, excuse me, that was my sneeze, 2x parentheses x minus 3 plus 1 times anything is itself, so there's going to be x minus 1 is equal to 2. So distribute here, I get 2x squared minus 6x plus x minus 1 equals 2. So I get 2x squared minus 5x minus 1 equals 2. Subtract 2 from both sides. So when I do this, I get 2x squared minus 5x minus 3 is equal to 0. And just like before, we are going to double bubble this to go ahead and see what gives us 0 as answers. So I'm going to go ahead and do this new way of factoring called AC method, which means that we do 2 times -3, and that's the number that goes at the top. So looking for 2 numbers that multiply to give us -6, and also that add to give us -5, add to give us this. And again, not everybody should be watching this video. This is for those of you that I said, hey, watch model 3. And so multiply to give us 6. So 1 and 6. Okay, so let's check that. 1 and 6. So this is negative. So it looks like this works. So 1 times -6 gives us -6. And 1 plus -6 gives us -5. So since this is called AM method, I'm going to bring that 2x squared down. I'm going to bring that -3 down. And this -5x is going to get broken up by positive 1x and -6x. So once I get to this point right here, I split this down the middle and I factor. So this is an x that is the same here. And what am I left with? 2x plus 1. And over here, if I factor out a -3, and I'm also left with 2x plus 1 equals 0. And now I take whatever is common. So you see this 2x. Let me pull this out. There we go. 2x plus 1 is common in both. So I'm going to write that 2x plus 1 in one of the bubbles. And in the other bubble, I'm going to write down what's left, which is x and a -3 equals 0. I'm going to set them both equal to 0. So 2x plus 1 equals 0 and x minus 3 equals 0. So subtract 1, divide by 2, and I get x is equal to -1/2. Do it and see if you get the same thing. And over here, add 3, so you get x is equal to 3. So now I have to go back and plug it in to see if there's anything that doesn't work. And automatically I can see that 3 does not work. Because 3 minus 3 is 0, so the 3 does not work. So I'm going to cross that out. And -1/2. That looks like it works. So the only answer is x equals -1/2. And again, you can use your calculator to verify. Check for understanding time.